y double dashed minus 12y equals cos x, and here's the initial conditions. So let's start off with the homogeneous equation. So here, y double dashed minus 12y is equal to 0. And so we can now write the associated auxiliary equation, lambda squared minus 12. There's no lambda term because there's no y dash equals 0. So that tells us then that lambda is equal to root 12, which is root 4 times root 3. So root 4 is 2, so that's 2 root 3. Plus or minus, isn't it? So we got our two distinct roots, so it's case 1. So case 1 then gives y is equal to a e to the first root, which is 2 root 3, say 2 root 3 times x, and then plus b e to the minus 2 root 3 times x. There we go. So that's case 1 then, and that's yh. So we've done that part of the problem. Now we turn our attention to yp, and we try y equals, so let's go down to our table, see what we need to try. Here it is here. We try a sine plus b cos. So it's a sine x this time, plus b cos x, because the right hand side was just 1x. So y dashed will equal a cos x minus b sine x, and y double dashed minus a sine x, yeah, minus b cosine x. There we go. So that's what we've got. Substitution then. So subs gives. So substitution gives. Okay, y double dashed, one of these. So minus a sine x minus b cos x is just one of them, so we don't need a bracket. Minus 12, so we do need a bracket now. Of the y, no, minus 12y, so we just need this here. A sine x plus b cos x. Close bracket equals the right hand side, which is just 1 cosine x. So we need to equate sines and cosines then. So let's have a look at the sines and see what we get there. Minus a minus 12a, and that equals cos, so there's no sines over there, so that's 0, so a is 0 then. And the cosines now, let's equate those. So cosines minus b, and then we get minus 12b, don't we? And on the other side, we just got 1 cosine, haven't we? Cos x, so it's 1. So minus 13b is equal to 1, so b then is equal to minus, bring the minus up to the top, minus 1 over 13. There we go. So this is yp, and we've done yh. Here's yh, so we can write down the general solution now, yh plus yp. So here a e to the 2 root 3x plus b e to the minus 2 root 3x plus the general solution. So we need the yp, don't we? And we worked out that a was 0 and b was minus 1/13. So it's a minus 1 over 13 cos x. There we go. Yeah, b is the cos 10 minus 1 over 13. So there's our general solution. Now we need to invoke the initial conditions. Y dash 0 is 2 and y 0 is minus 1. So 2 and minus 1. 2 and minus 1. So y 0 is minus 1 and y dashed 0 equals 2. So I'm just going to keep that there. I'd like to work out y dashed really. So I'm going to move those just slightly down so I can work out y dashed here. So y dashed then equals e to the something, the 2 root 3 comes down, like so, because it's a function, e to the something differentiates to e to the something. Second term then, the minus 2 root 3 comes down this time, b e to the minus 2 root 3x. And then the cos goes to minus sign, so that'll make that a plus 1 over 13 sine x. There we go. So that's y dashed. So this condition here then, what does that give? Y naught equals 0, so when x is 0, y is minus 1. So minus 1 equals e to the 0 times a is 1. E to the 0 again times b is just b. And then cos 0 is 1, so we've got minus 1/13. So that tells us then that a plus b will equal minus 1, move that to plus 1/13. Minus 13/13 is minus 12/13, isn't it? So that's equation 1. A plus b equals minus 12/13. Let's have a look at the second one now. Turn our attention to this. So, when x is 0, y dashed is 2. So 2 equals, e to the 0 is 1, so that's 2 root 3a. And then we've got minus 2 root 3b. And then we've got that's equal to, that's it really, because the sine of 0 is 0. So that tells us then. So I'm going to divide by 2 root 3 all the way through. A minus b equals 2 over 2 root 3. When you have that, it's the same as 1 over root 3. So I can write that as root 3 over 3, really. Just rationalize the surd in our mind's eye. So are we all happy with that? Divide by 2 root 3 here and here and here. We get a minus b here. I've written it down right to left. And then 2 over 2 root 3, the 2's will cancel. And 1 over root 3, you can just rationalize the surd. So check that if you need to. So now we can just add them. 1 plus 2. What does that give then? 2a equals, and then we add these numbers up. So we've got root 3 over 3 minus 12 over 13. Not nice. So should we get the decimal? I think so this time, because it's not a nice surd, is it? So we've got root 3 over 3 then. So root 3 divided by 3 minus 12 divided by 13. Okay. Well, there's the surd. And again, it's not very nice. So let's get the decimal. Minus 0.35, isn't it? It's 2dp. Minus 0.35. So a equals then. Well, let's go back to the calculator and divide that by 2. Because then we're going to get an accurate answer. Okay. Minus 0.17. Okay, so a equals then minus 0.17 from the calculator. Okay, good. That was to 2dp. And this is to 2dp. Okay, there's a. So now we need b. So b equals then, from here, minus 12/13 minus a. So that would be equal to, a is minus 0.17. So that's 0.17 then, isn't it? Minus 12/13. So on my calculator, because I've got minus, if I just add 12/13, if you see what I mean, divided by 13, then that one answer will have the opposite sign. The 0.75 is the answer then when you tap this in the calculator with a minus. Minus 0.75, and that was to 2dp, wasn't it? Yeah, that's fine. Okay, so check that if you need to on a calculator. There's b. So we can write down the final answer then. Here's our general solution here. So let's write down the answer then. So y equals then a is minus 0.17, e to the minus 2 root 3x, plus b, which is minus 0.75, e to the minus 2 root 3x. Now one of them is a plus, that's a plus, minus 1/13. Yeah, cos x, there we go. So hopefully we put the values in correctly now, and we've got the particular solution for the differential equation.